Okay, we're given a function, it's a quadratic, and we're given a linear. State the quotient and remainder of, if you take a function f of x and divide it by g of x. So that's just, and they want it in this form, which is the form that we would do if we did long division anyway, so don't get caught up with that. It's just f of x, which is 3x squared plus 7x minus 20 divided by x minus 2. So we start the long division. X times what gives us 3x squared? That would be 3x. We multiply 3x by this whole thing and line it up, so we get 3x squared. 3x times negative 2 is negative 6x, and we do subtraction in between each term. So 3x squared minus 3x squared gone. 7x minus negative, so 7x plus 6x is 13x. Bring down your negative 20. X times 13, we repeat the process, and gives us 13x. So we take our 13 times x minus 2, which will be 13x minus 26. Do our subtraction. Again here, be careful of your signs. Negative 20 minus a negative. Negative 20 plus 26 is 6. So that's your remainder that we add on. And we always keep over the divisor. So there would be our final answer. Okay, so this is your q of x, 3x plus 13, that's your quotient, plus your remainder, which is 6 over x minus 2. Now, to check, to make sure that we got this right, was our remainder supposed to be 6? This is where the remainder theorem can help you as a checking mechanism. Was our remainder supposed to be 6 when we divided by x minus 2? We would try f of 2 then. Okay, our remainder theorem says that whatever we get when we do f of 2 should be our remainder when we divide by the factor x minus 2. So if I plug in 2 over here, three times 4 is 12, plus 14 minus 20 gives me 26 minus 20 gives me 6. So the fact that I got 6 tells me that my remainder should have been 6, and it was. Not necessary. This is not necessary and would not be graded at all as a part of the problem. This is the problem, but this is just an example of how the remainder theorem can help you as a checking mechanism for long division, or to come up with a remainder if that's all you're asked without having to do division. So if they just said, what would the remainder be, you don't have to do that. You could just do your remainder theorem. Alright, so we are algebraically determining the values of h and k to correctly complete the identity. Remember, in an identity, you want your left side to equal your right side. So we're going to try to find h and k to make that happen. Now, it starts with simplify out each side. Left side's already simplified. On the right-hand side, I'm going to have to do multiplication first. X times 2x squared is 2x cubed. X times hx is hx squared. X times 3 is 3x. Keep going. Negative 4 times 2x squared is negative 8x squared. Negative 4 times hx is negative 4hx. Negative 4 times positive 3 is negative 12. And then we have the plus k. So typically we would now combine like terms, which we can sort of do. We've got 2x cubed, and that's that. Which is good because this side has a 2x cubed. Okay, then we've got our x squared terms, which is two of them. We can't exactly combine them because we don't know what h is, but we can bring them down. Now, here's where we're going to get h. Okay, this is supposed to be a negative 10x squared. So in order to make this an identity and make them equal, we want this to become negative 10. So h would have to be a negative 2, so that when you combine a negative 2 with a negative 8, you get negative 10. So h equals negative 2. Okay, we go to our next term, which is just our x's. So plus 3x minus 4hx, those are our x terms. So this 3x minus 4hx is supposed to be our x term, and it's supposed to combine to be positive 11x. And we already said h was negative 2, so we can just double check that. That 3 minus 4 times negative 2 would be plus 8. 3 plus 8 does give us 11. So our h is confirmed as negative 2. And then our last term is going to be negative 12 plus k. That's going to be your constant. We want that to equal negative 7. So what would you have to add to negative 12 to get negative 7? And that's going to tell you that k needs to be a positive 5, because negative 12 plus 5 will be negative 7. And there are your answers. Okay, so on this next one, it's a longer problem. Elena is running the Buffalo Half Marathon in May. She researched training plans. She's looking at 2 possible plans. Jillian's is with the dots. Jillian seems to be a perfect linear approach, where every additional week, she's running 1 more mile. So at the 1 week mark, she's running 10, 2 weeks 11, 3 weeks 12, 4 weeks 13. Josh's plan's a little more interesting. He's running 1 more mile, then 1 less, then 1 more, then 1 more, then 1 less, then 1 more, then 1 more, then 1 more, then 1 less. So his is a little interesting. Which one follows an arithmetic pattern? Arithmetic means we're adding the same thing every sequential week in this case. So that's definitely Jillian's. Explain how you arrived at your answer. Jillian is adding 1 mile every additional week. Adding 1, adding 1, adding 1. If you wanted to, you could even say 10 miles, 11, 12, 13. This is her sequence. This is how it's going. And that's plus 1, plus 1, plus 1. But that sentence should be enough. Write a recursive definition. Okay, before I even read on further, a sub 1 equals a sub n equals. That's how recursives go, and recursives take the previous term, which is a sub n minus 1, and they do something to it. So write a recursive definition to represent the number of miles run each week for the duration of the plan you chose. I chose Jillian's to answer part 1. And so the recursive formula would be her first week she ran 10, so a sub 1 is 10. And every week thereafter she is running the same amount that she ran the previous week plus 1. That's it. So Jillian's plan has an alternative if Elena wanted to train instead for a full 26-mile marathon instead of the half. Week 1 would start at 13 and follow the same pattern. So then week 2 would be 14, 15, 16, 17, and so on. But it would continue for 14 weeks. So this is a sub 1, a sub 2, and we're going all the way up to a sub 14. Write an explicit formula. There's our sheet. Arithmetic explicit. We're going to pull that. I'm going to write that here. A sub n equals a sub 1 plus n minus 1 times d. And write an explicit formula in simplest form, so we're going to have to simplify this out, to represent the number of miles run each week for the full marathon training plan. So a sub n equals, our a sub 1 was our first week 13, plus n minus 1, and our common difference, plus 1 plus 1 plus 1. So our common difference is 1. So in simplest form would just mean distribute your 1, which doesn't do much, and then combine your 13 and negative 1. And there we go. They didn't ask it, but now we could say, okay, what would she run in the 14th week? So a sub 14 would be 12 plus 14. She would run 26 miles in the 14th week. All right, we have a couple more questions here. Guidance department has reported that of the senior class, 2.3% are members of the Key Club, 8.6% are enrolled in AP Physics, and 1.9% are in both. So when I see 2 overlapping sort of things, I'm thinking Venn diagram. So we've got our Key Club, and we've got our Physics. Now, 2.3 are members of the Key Club, so here and here, which is the Key Club circles, have to add up to 2.3, but I don't know how it's split. 8.6% enrolled in Physics, so my Physics circles have to, or Physics sections of the circle have to add up to 8.6. But this is huge. They gave me both here, so immediately I know that 1.9% do both. So now I can work from the inside out. So if the key club total was supposed to be 2.3, well, I already have 1.9, so I'm only missing 0.4. Those add up to 2.3. And then the physics total has to be 8.6, and I've already got 1.9 accounted for, so 8.6 minus 1.9 leaves me with 6.7. Okay? And then the percentage of people doing neither, not that we necessarily need to go this far, but doing neither, these three added up, 6.7 plus 1.9 plus 0.4, accumulates to 9%, so that means 91% are doing neither. But anyway, determine the probability of P given K. So P given K is telling me I should only be looking at the K circle. So out of the K circle, so out of those 2.3, what's the probability that any of these people also do P? And that would be 1.9. So 1.9 divided by 2.3 is going to give me my probability of 0.826086965. They want the nearest tenth of a percent, so I need to change this to a percent, which would be 82.6086965%, and then round the percent to the nearest tenth, so that's 82.6%. This is the probability. We do not want to round this to 0.8. They didn't want the probability to the nearest tenth of a percent, or they didn't want the probability to the nearest tenth. They wanted the percent to the nearest tenth. The principal would like a basic interpretation. Write a statement relating your calculated probabilities to student enrollment in the given situation. Okay? So, given that someone is in the Key Club, they have a much larger chance of also being in physics. Because physics alone, they only have an 8.6% chance of being in physics if you're looking at the whole school. But if you're limiting your population to just the Key Club kids, now your chances of being in physics have risen from 8.6% to 82.6%, which is huge. So if a student is in the Key Club, the probability of him being in physics really skyrockets. I'll even use that word, skyrockets, to 82.6% versus only 8.6% otherwise. Okay, two more questions. Okay, we're using a formula below. We want to read through and see everything that's going on here. Determine the monthly payment. Monthly payment, this is what we're determining. On a 5-year car loan, where's the length of our loan? Number of monthly pay periods. So if it's 5 years times 12 months paying, that's 60 monthly payments. Monthly percentage rate of 0.625%. Monthly percentage rate, interest rate per month, so we don't have to change anything there. So that's 0.625. Well, this is given as a percentage. So your rate is 0.00625. And for a car with an original cost of $21,000, that's not what you borrowed though. The original cost was $21,000, and you already paid the down payment of $1,000. So you already paid $1,000 of it. So you're actually only borrowing $20,000. And we want to determine this to the nearest cent. So we're looking for PMT. So we would plug in a PN of 20,000 equals, I'm going to leave this PMT as X, 1 minus 1 plus 0.00625 to the negative 60th power over 0.00625. So I'm just going to come up with this number on my calculator, being very careful to type it in properly. So my entire numerator should be in parentheses. So 1 minus, and then a second set of parentheses, 1 plus 0.00625, close the first set, raise it to the negative 60th, close the numerator, divided by, and I'll just keep my denominator 0.00625 in its own set of parentheses. And I get 49 point, and I'm going to only write down 49.9, but you're going to see that I'm not going to really, I'm going to not use that number. I'll use this one to do my calculation. So I'm going to divide both sides by 49.9. So take my 20,000 and divide it by, and I'll go up and select that. Bring the whole thing down so I haven't rounded, and I get x equals 400.76. And I did 76 because it said to the nearest cent, and this is money. So the monthly payment will be $400.76. So the affordable monthly payment is only $300. So this person can really only afford a monthly payment of $300 for the same time period. Determine an appropriate down payment. So we kind of need to figure out what loan amount they're allowed to take. So this one, they took a $20,000 loan amount, which was too much. They still had a monthly payment of $400. We need to figure out, well, what loan amount should they take? So I'm going to go back to my original, and now I'm not looking for the monthly payment anymore. I'm going to try to figure out the amount borrowed. So the amount borrowed equals, I only want a payment of $300. And this whole thing is going to be exactly the same. So I'm going to just use the 49.9. Remember, I still have on my calculator that 49.9 full number. So the amount of my loan, remember, this is my loan, should be 300 times, and I'll go grab that 49 number. I should only be taking a loan of $14,971.59. So what should my down payment be? Okay, well, the car cost $21,000, and I am going to take a loan out of $14,971.59, and so that means I need a $6,028 down payment. Okay, so if the car costs $21,000 and then I make this down payment, now my loan will be exactly this amount and will allow for the $300 monthly payment as opposed to the $476 payment. Last one. The speed of a tidal wave. In hundreds of miles per hour, and speed is given as s, hundreds of miles per hour, that's huge, can be modeled by this equation, where t represents the time from its origin in hours. So t is in hours. Algebraically determine the time when s equals 0. So when will the tidal wave be going 0 miles per hour? So we're just going to take a look at this. It is a radical equation, because your variable's under the radical. You need to get the radical all by itself. So I'm going to add the 2t over. I'm also going to subtract the 6 over. So I have 2t minus 6 equals root t, and now I square both sides. So this side's going to become 4t squared, minus 12t minus another 12t will be minus 24t, and then plus 36. If you need to expand that and do it out, please do, to make sure that you're accurate. Equals t, and then I'm going to subtract this t over. I get 4t squared minus 25t plus 36 equals 0, and then I'm going to factor this. So if I want to cheat a little bit, because that's a tougher one to factor, I can type this in and see where it equals 0, and it looks like at 2 and 4-ish. So I might try 4t and t, and since it crossed at 1, 2, 3, 4, I might try a factor of t minus 4. This would be 4t minus 9. And that works, because this is going to give me the t equals 4 answer. But look at 4t squared minus 16t minus 9t will give me the minus 25, and negative 9 times negative 4 is the 36. You could get that without doing it. If you didn't want to factor, you could just do the quadratic formula. You'll still get t equals 9/4 or t equals 4. So after 2.25 hours or 4 hours. And then how much faster was the tidal wave traveling after 1 hour than 3 hours? So you want to find the speed at the 1 hour mark. So speed at the 1 hour mark. And you want to compare that to the speed at the 3 hour mark. Remember, this speed is in hundreds of miles per hour. So this will be 1 minus 2, negative 1 plus 6 is 5. The speed is not 5 miles per hour, it's in hundreds. So that's 500 miles per hour. This one, if I do type that in my calculator, the square root of 3 minus 2 times 3 plus 6 gives me 1.732. Again, that's not 1 mile per hour. That's, that's hundreds of miles per hour. So that speed is actually 173.2 miles per hour. So to the nearest miles per hour, if I just subtract these, how much faster is it going? 500 minus 173.2 is, I'll justify and show my work here, minus 173.2 leaves me with 326.8 miles per hour, so 327 miles per hour faster. And that is the end of January 2017.